All right, so I guess we'll get started. So thanks for attending the talk. It's the after lunch talk. So we'll talk about how FlawCheck and myself have been helping enterprise customers set up secure container development pipelines, particularly and often in Jenkins environments. So my name is Anthony Bettini, the founder and CEO of FlawCheck. So what we're planning to cover, a little bit about kind of how we even got here. Like why are people using Jenkins? Why are they using Docker? Who's using it? Why do they care about security? And why is this a pressing matter? So a bit of background on myself. I've spent pretty much the past 20 years in some shape, form, or fashion on a technical level in cybersecurity. My first job actually in forensics, working for an ISP back in the mid-90s that was compromised, had their billing database extracted from a core dump file by someone who had compromised the system, did a GDB attached to a core dump file, and then pulled out all the credit card numbers, posted it to Usenet. All their customers drained about 72 hours. That was my first experience with a breach, and I've basically been spending my time past 20 years on that similar kind of problem, but with an emphasis and focus on application security. And I'll talk about in a moment how that kind of all ties together with Jenkins. So before we get into the Jenkins and software development lifecycle, I thought we'd talk about who's even using Docker and who we see as our customer base at using Docker. How many people in the room use Docker today? Oh, okay, great. So Datadog put out this great survey they did, surveying their ecosystem on who's using Docker. And the general takeaway, lots of great findings in that, but one of the big takeaways was that enterprise usage far and away is what matters in the Docker ecosystem. Certainly, generally every developer we talk to, our team, they all love using Docker on their laptop and everything. But who's using Docker in the data center? It's large enterprises, it's cloud service providers, it's government. And this really aligns well with the Jenkins ecosystem. So, this is some data from CloudBees. It's a bit dated at this point, and it's a kind of sort of on how you have to infer that this relates to large enterprise usage. But make a long story short, when we're out there talking with customers, virtually 100% of enterprises we talk to use Jenkins. 100% are using Docker. Doesn't mean they're all using in the data center. It doesn't mean at large deployments. But they definitely have initiatives going on using Docker. They'd like to continue using that and particularly push it into operational environments. And they're happy with Jenkins today. And if you look at the application security testing market, this is the Gartner Magic Quadrant for that, the most recent one. Generally speaking, these are all enterprise products. And why this relates to the Jenkins kind of Docker trifecta is if you're out there, asking yourself, who cares about the cybersecurity problem, and who cares about that regarding developers pushing out new code and pushing out as fast as they can and trying to push that into a data center and deploy it to large-scale applications, ultimately you start seeing that the trend would be it's enterprises that use Docker, it's enterprises that use Jenkins, and it's enterprises that buy cybersecurity products, particularly when they're trying to secure software. So as we like to say, it's all roads lead to enterprise usage. So they generally have the most to gain by switching to something like Docker because they can squeeze more compute, more resources out of a data center at lower cost. So the trend we see is governments around the world, cloud service providers, the largest enterprises are all looking at Docker, trying to adopt it as fast as they can ultimately, which could be slow because they're very large organizations. But they have a large vested interest in this. And because, like time and time again, when we're seeing CI/CD products, our product itself integrates with generally all of them. What we see is that there's basically the Jenkins camp and everything else. everything else works really great if you're building a very non-complicated build process. More simplistic software, smaller teams. But once you start having regression testing and very complicated build processes with lots of teams and lots of systems involved, pretty much everyone is using Jenkins at that point, and particularly in the enterprise. And when it comes to securing data, certainly the more valuable the data, the more people care about securing that. Again, it's back to enterprises who are trying to spend money, spend time, and spend dollars on trying to secure that data. But the past 10, 15 years, especially the past handful, software development lifecycle has changed quite a bit. Obviously no one's talking about waterfall nowadays, but all of the security processes inside enterprises were built around waterfall. And we'll talk about that in a bit. So more modern software development lifecycle. This is, there's a lot of different people who have put out charts kind of trying to juxtapose, what's the difference between DevOps and CI/CD, and where are your organization on the maturity curve for building software. In this case, waterfall is not even on the maturity curve. But a lot of large businesses we talk to today, imagine you're a regulated bank. There's some out there today that are doing some of these processes, but a lot of them aren't. They've built their teams, their technology around older legacy solutions, and they're really struggling with this. And I think what's particularly interesting is all of the security technology, especially the processes, not the products, but the actual processes, have been built around waterfall, even though generally speaking, new software development today, especially at smaller companies, definitely is not taking place in a waterfall-based development methodology. So just to catch you up on how people were even, especially large enterprises, were attempting to secure the software development lifecycle before containers, before DevOps. They largely turned to the Open Web Application Security Project. So obviously not all applications are web applications, but this organization was out there. They make a lot of noise. It was founded in 2001, so it's been around a long time. A lot of their team is kind of embedded within Fortune 500. They also have a lot of feedback from MITRE, the PCI organization, DISA, which is the IT arm of the Department of Defense, Federal Trade Commission. So a lot of big organizations that are actually developing a lot of software, mostly used in-house, that are turning to this organization and trying to support it on helping organizations secure the software they're building. So one of the initiatives that we're more famous for is what they call the OWASP Top 10, so the Open Web Application Security Project Top 10. And so these are supposed to be the top 10 security risks that apply to web applications. As you can see, from 2010 to 2013, it's changed a bit. But because there's a lot of big organizations behind this, doesn't change so often. So here we are today in 2016, and the current version is this 2013 list. And obviously, apply this to Jenkins. Not every piece of software you're building is a web application, but there isn't anything similar to this organization putting out, process documentation or guidelines or auditing documentation for C++ applications or for Java applications. So even if this is, all geared towards web applications, it is kind of like the round peg in a square hole problem that gets reapplied by all of these other enterprises that are developing software to their existing application development lifecycle. So they start checking for these things. They start buying products to check for them. Some of the things you can see is, like, for instance, A9, using known vulnerable components. That certainly applies universally. It has nothing to do with web applications. Would apply equally well to C++, Java, or mobile applications. But what's interesting is they even put out a CISO AppSec guide. It's what they help chief information security officers at these large global 2000 organizations embed security into their application development lifecycle. But if you think about how this SDLC gets laid out, there's a requirement step, a design step, you develop your application, you integrate it, you have pen testing, you validate, and then you push it to production. This is all written around a waterfall-based development methodology, and this was developed actually in around 2001, approximately when the organization started. But this is what they still push out to people today. So sometimes when we're out there and we're talking to large enterprise customers, they've started using Docker, or their development teams have, they want to push it to production. Maybe they're using GitLab for source control, they're building it into Docker, they're using Jenkins for builds, they want to push it to, like the dev team wants to push it to production, they contact the ops team. The ops team wants to insert this process on their DevOps process, and it's not really working out. So the carpet's kind of been pulled out from the CISO's organization in the sense that DevOps today basically puts ops in the control of dev, particularly when Docker's involved, because how the build specifications on the application are contained within the Docker container, and they're specified in the Docker file, thus ultimately controlled by the developer. And the intent would be that that's just pushed over the wall to ops, it's released through some type of potentially automated process, but that doesn't fit with how they're trying to secure the software development lifecycle, and it doesn't fit with the quote-unquote best practices for security of these third-party organizations they're talking to, like the OWASP project. So, there's a lot of high stakes involved in this. Like, for instance, this is a more modern example of a software development lifecycle kind of charted out. And there's some things missing from this, and obviously everyone's a little different. But this is kind of a more modern equivalent. And then this is a more high-level, more simplistic equivalent that then tries to map that SDLC process to Agile, CI/CD, DevOps. But in both of those cases, security isn't a bucket. It's not mentioned as a key step in any of those pieces. And if you then try to retroactively, connect those more modern SDLCs to like the OWASP, security guidelines, particularly for CISO, it doesn't map so well. And then they're really struggling with this. And so the organizations they turn to ultimately don't have a solution today. And what this causes on the enterprise level today, in many of the organizations we talk to, is the ops team then ultimately, let's say, presses the stop button, tries to run all these manual tests, potentially involving third parties, potentially involving in-house purchase tools. In the DevOps cycle, and particularly the CD cycle, there's a halt step. And that's not what anyone wants, but ultimately the landscape has changed, and the security products haven't kept up with the change. And so what we see is a lot of the enterprise companies we talk with, they either start slowing down the process to insert all of these security controls, or they say that there either isn't a product or isn't a solution or this kind of thing, and they just blindly allow it to go into production, or it's held back and never even reaches production. And so this is a survey that was Red Hat had commissioned Forrester to survey enterprises about ultimately why was there so much dev usage for Docker but so much lack of Docker in the data center. And what Forrester found was the top concern holding containers back from the data center was security. But security is a giant topic. There's authentication and authorization. There's the vulnerability topic. There's the aspect of like breaking out of a container, controlling the container host, and then the whole data center is compromised. So we had done our own survey trying to dig into this a little bit. So we had surveyed a lot of enterprises asking, which piece of the security puzzle are you actually most concerned with? And what we found was they were actually most concerned with this application security testing problem, what's actually in the Docker container. Because what they are using inside the enterprise to do builds is Jenkins. They're typically using like the CloudBees build and publish plugin to actually build applications into Docker containers. And then they want to push those to production, but then the tools they're used to buying, like Fortify, don't actually support Docker containers, so they can't actually check them or inspect them. So then they have to come up with kind of convoluted processes to insert security controls throughout a changing software development lifecycle. And they struggle a lot with this. And this all relates to actually getting the application into production, running in a data center, and fully supported by what's typically an ops team inside an enterprise. Obviously, we all talk about DevOps nowadays. Any job listing you'd ever see at a startup has DevOps postings. But you go talk to, a large genetically modified seed manufacturer or a large financial institution. They may have jobs like that, but typically they have dev teams and they have ops teams. And they are still different. And maybe that will change, and maybe it will change in a year or 6 months or something like that. But today it is still different. And so they're expecting those application security testing tools to work in these complex build environments, typically powered by Jenkins. And the reason we see Jenkins as kind of key to this whole ecosystem is, we sell enterprise security software. We're out there talking with the enterprises, both our existing customer base and potential customer base every day. And we're talking with them about, which CI/CD system do you use, which build system, how did you arrive at this decision, all of these kinds of things. Way over 90% are using Jenkins, and that ends up being it could be because they love Jenkins. Certainly, some of them that's the case, but typically it's actually they have so much going on with such complex processes. It's process of elimination where that's the only thing they can use. Or at least that's what they believe today. And so they have this kind of common questions we hear time and time and again, which is how do we insert application security testing into these more modern build pipelines? So they're using, whether it's Jenkins 1x or 2x, they're trying to squeeze, they have like a very complicated build pipelines, and they're trying to squeeze security controls. Sometimes that's like static analysis of source code. Sometimes that's web applications being tested with specifically web application testing software. Sometimes Docker's involved, usually it is. And then they're trying to check for security violations, particularly if they're regulated industries as well. They could be regulated by PCI, they could be regulated internationally by Basel, things like that, or Sarbanes-Oxley. They ultimately need to make sure that they're checking all of the boxes and releasing safe software to production. And then even if they do all of those insertions at all of the right points in the pipeline, then there's the question of, threat landscape changes every day. New vulnerability in OpenSSL was just announced. Which of my containers and which of my applications are running in which containers in production that have that vulnerability, and how do I remediate it without taking down the users that are then connected to those applications? So what we see enterprises trying to build at a high level is something akin to this. So maybe they're using GitHub Enterprise or GitLab to host source code on premise. They're presumably using Jenkins to do builds. They want to make sure that those builds are free of malware, so they want to have some type of malware inspection process. And even for organizations that have a high degree of confidence developers aren't intentionally putting in malicious code or things like that. Certainly, open source is all the rage nowadays. People are pulling in code from third parties. Maybe they're pulling in code from a partner. The organization doesn't necessarily have the same degree of trust for that third party, whether it's open source or closed source, as they do for their own developers. So first step is typically they want to check in some form or fashion for malicious software. After that, then they want to start checking for vulnerabilities. That could be known vulnerabilities, like in the case of OpenSSL or glibc, being bundled in with the application. They want to know the application that, let's say, is in the Docker container is not vulnerable to some known vulnerable third-party open source component. But it also could be unknown vulnerabilities that are inside some C++ or Java or Python or Ruby on Rails application that's inside the container going through this build pipeline. And then after checking for that, then they have this question of, well, how are we enforcing policy? Meaning, separate from the question on the pipeline of like, does it go to production or not? There's the question of, well, maybe it's a large application, it's legacy, it's already running, a new vulnerability was just found, but maybe it's in a component that isn't necessarily accessible, and so even if it's high risk because it's not accessible, maybe by policy it would still be allowed through. Or maybe it is an accessible component, but the vulnerability severity is so low and it's so unlikely to be exploited in the wild that they're comfortable with it going to production. Because of the fast software development lifecycle changes that are happening, particularly with like continuous deployment, they would like to make those policy decisions on an automated basis without inserting humans into the process if possible. Today, because that isn't always possible, they often are inserting humans, making human-based decisions on that, but they would certainly prefer an automated step. And then in the case of Docker container ecosystem specifically, there is this then question of the build artifact, and you would have this same analogy in Java applications that are being built or something similar, but or even enterprise mobile applications. But there's this build artifact, the Docker container, that hosts the application, that went through regression testing and security testing, that needs to be stored somewhere. And in the case of Docker containers, it's not just stored on disk in a tar file, it's technically stored in the Docker registry. In the case of enterprise usage, that would typically be an on-premise registry, and then it would be accessible only by API and thus accessible via like the Docker command line tools. And then once all of that's been approved and the build artifact is being stored somewhere in some on-premise registry, then Docker in production would pull effectively the gold image for that Docker container from that private registry. So this is what FlotChecks helps people with. So what we have is we have a private registry. It does all the security scanning. And then Docker in production gets the container registry from us. So this is how we typically see architecture within enterprise organizations. And certainly this isn't, I mean, some of this is specific to our product, but some of it is not. Like, there's lots of organizations out there that all scan Docker containers or totally separate from Docker and the container ecosystem that'll scan applications that you're building for lots of different things, whether that's source code or binaries or web applications. But this is how we've approached the problem to securing DevOps environments for enterprises based on their needs. Because typically what we're finding is they are using Jenkins. They're either using GitHub Enterprise or GitLab. Lately we've seen most people are using GitLab. They're doing builds with Jenkins. And they have the Cloud Beast build and publish plugin on the Jenkins host. The Jenkins slaves and the host are all running the Docker daemon. So they're building the Docker containers. And then they need to push that to their on-premise registry. In our case, that's when we do the checking when we've received it from Jenkins. So what we help people with is the same thing that Customs and Border Patrol does at Oakland or does in Long Beach or Newark, which is we crack open containers, check for bad stuff. Certainly we offer a free trial free tier. These are the plugins we most commonly see. As I mentioned a couple times, we see the Codebase Docker build and publish plugin all the time. That's typically what we see people using to actually build into Docker containers right at the Jenkins level during the pipeline. We're seeing all the event hooks get monitored either with the GitHub plugin or the GitLab plugin. And so I think what we think is kind of interesting is the general landscape or ecosystem of stakeholders for secure development pipelines really aligns with the trifecta of Docker, Jenkins, and application security testing. And when we are out there talking to customers, that's really just the largest of the large enterprise, which we would include as like cloud service providers and government as just types of that. But it's the largest organizations of the world. It's not the small startups. But what's kind of interesting is, because there's so much, like let's say startup usage of something like Docker, that's basically the consumerization of IT trend that's caused all of these enterprises to start on using something like Docker, but then they get stuck because they are trying to, their ops teams are trying to put basically security processes that were built for waterfall on CI/CD, and they get stuck with that. All right, I guess that's all I had. Certainly, if you have other questions, feel free to grab me. I'll be here all day, be here tomorrow. Thanks a lot.